Currently, our center has 36 members, and our research focuses on past, present, and future climate change, ice sheet instabilities and sea level rise, and ocean acidification. Ocean acidification refers to the fact that about 30% of the CO2 emissions, man-made CO2 emissions, will end up in the ocean. There, they create a reaction, chemical reaction with seawater, which leads to a reduction of calcification rates. This in turn dramatically impacts calcifying organisms such as corals, shells, crustaceans, with ripple effects for the entire marine ecosystem. To be able to predict future climate change, sea level rise, and ocean acidification with higher fidelity and accuracy, climate researchers need supercomputers. In collaboration with the IBS Headquarters Center, we are currently in the process of purchasing the third fastest computer in Korea. This new machine will enable us to conduct cutting-edge research and improve short-term and long-term climate predictions and projections. Let me just say a few words about our research portfolio currently. Scientists in our center work on past, present, and future rainfall changes, on the El Nino summer oscillation phenomenon, mega droughts, forest fires, ice sheet instabilities and sea level, as I mentioned before, ice ages, ocean currents, tornadoes, land-ocean carbon cycling, regional climate change, and atmospheric processes. So it's a rich research portfolio of a typical Earth system center. Let's talk now about actionable science. There is perhaps no official definition yet, but for me the key objective of actionable science is to develop applications and generate new insights and formulate new policies that will be beneficial for society, governments, non-governmental stakeholders. Actionable science oftentimes starts as curiosity-driven basic science, and it can lead to major paradigm shifts in policy and in society. Actionable science is not necessarily technologically or industry-driven, but it can have considerable impacts that can be felt in many sectors of society, including industry. A good example for actionable science actually comes out of my own research community. Under the auspices of the Intergovernmental Panel on Climate Change, short IPCC, which is administered by the United Nations Environmental Programme and the World Meteorological Organization, my community has provided key basic science information on the causes of climate change and its connection to our own greenhouse gas emissions. This information is compiled by leading scientists every 6 years. The fourth assessment report of IPCC had a fundamental impact on our understanding of man-made climate change. As a result, the IPCC was awarded the Nobel Peace Prize in 2007, not the Science Prize, but the Peace Prize. The 2013 fifth assessment report, which I had the privilege to contribute to, provided the scientific backbone for the negotiations that led to the milestone 2015-2016 Paris Agreement. In this agreement, more than 150 countries, including Korea, pledged to keep global temperatures below 2 degrees Celsius relative to pre-industrial climate. It is fair to say that our basic science community has led to major policy and paradigm shifts in society and humanity. As a result of this Paris Agreement, we will enter a new era of energy resource usage. This will be the era of decarbonization. I may be preaching to the choir here, but let me just remind ourselves of some of the key facts of the IPCC assessments. Number one is warming of the climate system is unequivocal. As can be seen directly by looking at the global surface temperature trends, most of the places that we see in the upper right figure are red, except for one little spot sort of green. Number two, human influence on the climate system is clear. This becomes apparent by comparing the observed global mean temperatures in black with the climate model simulations that do and do not include anthropogenic greenhouse gas emissions. Number three, continued greenhouse gas emissions will cause further warming. Very simple sentence, all climate models, computer models, one of these supercomputers, as I mentioned before, show an increase in surface temperatures for future projected CO2 changes. The magnitude of the future warming, however, will depend on our socio-economic decisions, whether we continue as business as usual in terms of CO2 emissions, or whether we follow a path that is in accordance with the Paris Agreement, will lead to a major change in the climate conditions that our future generations will experience. Furthermore, another important finding from the IPCC is that future warming will increase the likelihood of severe, pervasive, and irreversible impacts. As demonstrated here by the rapid decline of Arctic sea ice in future climate change simulations over the next 80 years, in the upper figure, and by the rapid retreat of the Western Arctic ice sheet, which can lead to sea level rise of up to 5 meters over the next 150 years, according to some of the latest ice sheet model simulations. Such a large acceleration of sea level rise will affect 700 to 1.5 billion people in coastal areas. You can see immediately that basic science, in this case, ice sheet modeling, also conducted in our center, can generate results that are immediately societally and policy relevant. Irreversibility of climate change means that many future generations can be haunted by the decisions that we make today. Our CO2 legacy will last for hundreds, if not thousands of years. To stay well below the 2 degrees Celsius target of the Paris Agreement, mankind can still emit 100 billion tons of carbon, which means that if we don't act soon, within the next 70 years, the 2 degrees Celsius target of Paris will be lost. Limiting climate change requires substantial and sustained reductions of greenhouse gas emissions. And this is illustrated in the graph below, which shows 3 different scenarios reducing our total emissions to below 800 billion tons. An early, less aggressive implementation strategy, a delayed, very aggressive path. Each party of the Paris Agreement, including South Korea, needs to discuss now what their preferred pathway will be. Measures need to be implemented within the next few years, actually, not few decades, the next few years, to reduce CO2 emissions in the energy sector, infrastructure, transport, land use, industry, and finance. Despite still being the largest contributor of greenhouse gas emissions, about 30% of the global emissions, China has realized that the Paris Agreement is also creating a new global market for their competitive renewable energy technologies. China is investing about $80 billion per year in renewable energy implementation and about $2 billion for respective research development. As a result of this effort, the global costs for solar panels have dropped by 70%, which makes solar energy an economically viable and competitive resource. China is on the way of becoming the monopoly for green technologies. Probably it's time to catch up for other countries. Decarbonizing our planet is not only an engineering problem. It is also scientific, political, as well as societal challenge. It requires us to change our behavior. decarbonization requires an approach where basic science becomes actionable science. It is science that is employed for the benefit of society and mankind.